as you see here, we have a 3 by 7 rectangle, and I want you to find the total square units that it covers. And the total square units that it covers is 21 square units. The reason why 3 by 7 is 21, and there are 21 unit squares. So it covers a total of 21 square units, and we have 3 shapes of tiles. 2 by 2 covers 4 square units. 1 by 4 also covers a total of 4 square units, and 1 by 1 covers a total of 1 square unit. So with that, we can eliminate some of the answer choices because it says what is the minimum possible value of 1 by 1 tiles used. So we want to find the minimum possible value of 1 by 1 tiles used. So let's just say if we use 2 1 by 1 tiles. So if we use 2 1 by 1 tiles and each tile covers 1 square unit, that means we know that if we have 2, it covers 2 square units. And if 2 square units is already taken up of the 21 total square units, that means we know that there's 19 square units left for the 4 by 1 and 2 by 2 to cover. So we know that 19 square units for a combination so the 2 by 2 and the 1 by 4 have to cover a total of 19 square units. And we know that is impossible because they both have a total area of 4 square units, and 19 is not a multiple of 4. So we know that is false. Well, we also know that, so we can cross out B. We also know that C is also doesn't work. For the same reason, 1 by 1, if there's 3 1 by 1s, it covers a total of 3 square units, and that means there's 21 minus 3, which is 18 square units left. 18 square units left to cover. And since both of these 2 by 2 and 1 by 4 cover 4 square units for each tile, that means we can make sure we can know that it cannot cover 18 square units. There's no possible way because it's not a multiple of 4. Okay, we can continue. And 3 doesn't, we know that 3 doesn't work. 4 also doesn't work because, as we see here, if we have 4 1 by 1 tiles, it covers a total of 4 square units, and that means that there is 17 square units remaining, and that is not possible if each tile can only cover 4 square units. So we know 17 square units are remaining. It's 21 minus 4, and it is not possible to cover using only 4 square unit tiles. Okay, so we have A and E, 1 and 5 for the answer choices left. Well, we can eliminate, so now that we're only left with 2 answer choices after we eliminate 3, we can do a little bit of testing based on where these 1 by 1 tiles are placed, and we'll notice that A does not work at the end, and the only answer possible is E. Draw a quick tree, and it will solve all of our problems. I'll show you what I mean. So he starts on Monday with $2. We don't really need to write the unit because everything is in dollars, and even the answer that we're going to give is in dollars. Okay, so he starts on Monday with $2. On Tuesday, he can either double it, or double it to 4. So 2 times 2 is 4, or he can add $3 to the amount he had on the previous day. So he either gains $3, so now he has 5, or he can double it. So there's two options. And as you see here, these are the two options. And I'm going to move this so it doesn't get in the way. So as you see here, 2 becomes 4 or 5. Okay, these are the different paths or options he can take. Okay, so on Wednesday, so now it's going to be Monday to Tuesday to Wednesday. And we can count the number of options he has. 1, 2, now he has 4. Okay, so he can either double the amount of money he had on Tuesday, or gain $3. So he can gain $3 or double it. So what this is basically saying, he starts Monday with $2. He chooses to gain $3, and he has two options now. He could either choose to gain $3 again or double his money. So that's what this tree means, and he could do that the other way too. So he can have 8 or 7. So what this is basically saying, he starts Monday with $2. He chooses to double his money, and now he has two options as well. He can either gain $3 or double his money. Okay, so now we're gonna move on to Thursday. And so he can either double his money or gain $3, double his money or gain $3, double his money or gain $3, and I'm just gonna write it here, double his money or gain $3. And I'll explain what all these numbers mean, but I'll just pick one portion of the tree to explain it to you. Okay, so he starts with $2, he gains $3, and he chooses to double his money after he gains that $3 on the next day. Now he has two options. He can either choose to double his money again, or he can choose to gain $3. So these are all the possible outcomes that he can choose after 3 days. And so the possible outcomes, we're going to start from the top. It can be 16, 11, 14, 10, 16, 11, and 13, and 20. And obviously, we're not going to count the overlaps. So 11, we want to make sure that there's only one 11 and one 16. So that means the only possibilities of the different dollar amounts that he can have 3 days later is 10, 11, 14, 15. Wait, is that a 13? Yeah, that's a 13. My bad. So he can have 10, 11, 13, 14, 16, and 20. So $6 amounts that he can have. D. We know that the marbles are red, green, or blue, and Maria has half as many red marbles as green marbles. So half as many red. So red is equal to half green. Okay, so R stands for red and G stands for green. Okay, and if you don't know how to translate this odd wording into a equation, you can very simply put numbers in. Like 5 is half of 10. Now, if 5 was replaced by red, then R is half of green. which is now 10. So that's an easy way. Just substitute numbers in, and you'll know the correlation between the variables. So they're very similar, numbers and variables. Okay, so we have another equation that we can solve, and it's twice as many blue marbles as green marbles. So the number of blue marbles is twice the amount of green marbles. Okay, so as you see here, we have two equations. We can simply solve, and we can find the total amount. So if we're trying to find the number of red marbles plus the number of green marbles plus the number of blue marbles, we can simply use substitution. So red is equal to half green, so we can put half green for in the place of red, and we can put 2g, or two times the number of green marbles, for blue, because we know we have that equation right here. So it's simple substitution, and we get 3g plus 1 over 2g, and that is equal to 7 over 2g. Now, it's asking for which of the following could be the total number of marbles in Maria's collection. And we know that the number of marbles is a whole number and a whole integer. So the only answer that is a multiple of 7, because we can simply multiply g can simply be, because g has to be an integer, so g can simply be 8. So if g is 8, then we can multiply by 8, because 7 over 2g, and this is the total amount. Remember that? Total amount. And if we substitute, or we have g is equal to 8, then 7 over 2 multiplied by 8 is equal to 28. Okay, so the answer is 28. This is simple science and graph problem. Well, it's a simple arithmetic sequence as well, but we want to first write everything down first. So 1980, the ppm level was 338, and the CO2 level was 338, and we're trying to find the CO2 level in 2030, and it says it increases 1.515 each year. So how many years are between 2030 and 1980? There's 50. You just easily subtract, and we multiply by 1.515 for each year. So basically what this is showing is that this is the change per year, and this is the number of years to 2030. So 2030. Okay, so this is the amount of it changes. Okay, so it's 75.75 with simple calculations, and we add that to 338 to get what we need, because it increases. It doesn't decrease, it increases. It says right here. So we get 338 plus 75.75, and we get 75.31 413.75. And if we have 413.75, we don't see an answer here. The reason why is because we have to make sure that we know what's asking for, or we respond to what's asking for. It's asking for your rounded answer to the nearest integer. Okay, so to the nearest integer, it would be 414. It would be B. So we have the triangle right here, and what we're going to do is write down everything we have. So the area is equal to 12, and the base, we also know the base by a little bit of calculation. So it has the same y coordinate, so we can just subtract the x coordinates to find the base, which is 6. 11 minus 5 is equal to 6. Okay, so the base is 6. So the base is 6, and that will help us find the height. So all I want you to do is find the height of the triangle. And this might be a weird triangle. However, we treat all triangles the same. We don't want to be unfair to any of the triangles that aren't don't look like a right triangle. So in a right triangle, we might have 6 and 8. This is just an example. 48, 6 times 8, 48 divided by 2 is equal to 24. That's the area. So we're multiplying its height by its base, and we divide by 2 to find its area. Okay, so so this is a basic formula. I do not want you to memorize formulas. Formulas are bad, and you just need to memorize the concept to actually get the to actually understand the problem and solve any variation of the problem. So base times height is equal to base times height divided by 2 is equal to the area of the triangle, area of a triangle, and we can use that to find it. So the base is 6, we're multiplying by the height, and then we're dividing by 2, and that's the area, which is 12. So the height is equal, so we can multiply by 2 on both sides. So 6h is equal to 24, h, and then we divide by 6, so h is equal to 4. Okay, since we know that the height is 4, we know the y-coordinate, because the y-coordinate is pretty easy. So the 7 is the base, and if we're increasing by 4, increasing the y-coordinate by 4, or increasing the height or vertical by 4, we know that it is 11. And we know that this is the same because it's on the same vertical, it has the same vertical plane, and yeah, so the answer is D.